Hello, and welcome back to our series where we are building a people and culture management system. This series is brought to you by Prairie HR Solutions. My name is Jake Finger, founder and principal consultant here at Prairie HR Solutions. And we are particularly focused on this salary analysis dashboard here. And if you've watched the previous videos, you should know where I'm getting this from. If you haven't, I highly suggest you go back and watch this because we built this from scratch. This data comes over to us dynamically from an employee database, and it is used to populate this data. This is obviously all of our employees, and we can filter it by division. We can filter it further down by, age. We can also do it by job title and then filter those down by, whatever. So it's becoming pretty darn dynamic. What we would like to do now is actually be able to use it to predict or um, run some typical compensation analysis. And I created the legend up here. This is going to go away because I don't think there's any reason why we need to um, have a user hover over this to see. I mean, chances are they're not really going to know what it means anyway. But anytime that we are running a compensation analysis, we should find the R square as well as the linear regression. And what that'll tell us is the correlation between, one, it'll tell us, the slope, and it'll also tell us if it's positive or negative, but it'll also tell us if there's a correlation between, in our case, salary over experience. And I mean, you can see that by looking over here. It's nice to have it here, the numbers. So I created two different fields, and you'll see that this is obviously the R squared, and this is obviously linear regression. So to get this little R square, I did get a comment or a question in one of the previous videos on how to create this subscript, and I'll show you how to do that. It's just a simple code that we write inside R and 2, and then it'll make this a subscript in upper subscript. That way you're not having to write out R squared. It's looks like that. It looks a lot nicer. So the first thing I want us to do is to populate this R square. So if you come over and hover this, you'll see that the R square for our customer service representative is 0.012. Now, what that means is since it's positive, the slope is positive. This means that there is a positive correlation of 0.012 that our salary amounts are based on experience. Now, looking at this data, you can see that, okay, yeah, it's positive. However, there's a lot of anomalies here to where you have people paid significantly higher and significantly lower. So our R squared should typically, the closer you are to 1.0, the greater the correlation is. So 0.012 is not that great. Yes, it's moving up kind of in the right direction, but having that correlation, it means that there is a very, very, very slim chance that you are paying your salary based on experience consistently. So let's go ahead and jump into and find this R squared. And Google, although Google does calculate the R squared in this legend, Google Apps Script is not like, say, Python or MATLAB or whatever. It's not really designed to do those hardcore calculations, and it's not really necessarily hardcore, but it's just not intended to do that. So we could approach this one of two ways. We can either jump in and use a library API and call that library over, but I would rather write our own code just so if you're following along and building one of these yourself, you'll have the function to find not only linear regression, but the R squared. And this episode, we will focus specifically on our R squared, see where we are at on time. And if we have enough time, then we'll go ahead and toss the linear regression in here. So let's jump right in. I'll try. I promise I'll do the best that I can anyway to not turn this into a statistical tutorial for HR. But you can either follow along with me, or you're just throw your hands up and say, "Nope, I did not join HR for math," and I'm just going to go to the very end of the episode and steal the code. If you go that second route, go ahead, steal with pride and prosper. So let's go over here to our code, and I want to first show how we're getting that subscript. So let's come down here to our, okay, here we go. So these are our elements for our linear regression and our R squared. Now you see how I have R and 2? When you add this ampersand and SUP, that automatically tells it that that next digit is going to be subscripted upwards. So that's how we were able to do that. And of course, linear regression is just that. So you can also do this with like log. If you ever had to do it, you just it's not this, it's something else that's lower, but same principle. But it renders very nicely on HTML. Okay, so now let's get into the fun part. So as I was mentioning earlier, although Google calculates the R squared and we're populating it and we're showing it in the legend, which is our trend line here, and it's going to be a linear, there's no real way to jump into the charts API from Google and carve out this R squared. Like I said, it's just not what it's for. And we're not going to jump over to a new API. We're going to do this programmatically. So what we're going to need to do is once this chart here, let's go back up here and populate it. So once it gets done running and fills all its data up and has all this data available as well as this trend line, we want to jump in there and calculate. We want to calculate the R squared and a bunch of other calculations. So to do this, we essentially need to grab the point in time in which it has the information, but it hasn't populated anything yet. So let's find out where that actually occurs. So right here, we're running through our for each. We are populating our data table here. And then we're running our calculations to fill those input box. And here we are declaring, we're not building the chart yet. We're declaring this chart variable equals this new scatter chart. And then here we are building it or drawing it, so to speak. So we can put something right in here. We can jump in and say, pause before you start drawing. We're going to do this stuff first. And what we're going to want to do here is calculate the R squared and then display. So to do this, let's create, we're going to need to call a lot of helper functions over. And those helper functions are going to run our calculations. So let me pause just for those who don't have any idea what it is that I'm talking about, which is okay. Who may not know what an R square essentially is or any of that. So what an R square does is in R square explains within the data the correlation confidence or level, I guess you could say, that each point is based on what it's supposed to be. So that's the non-mathematical way of saying it. So what it's basically saying is that if this salary, if we're paying salary based on experience, if that's truly what it is we're trying to do, then we should be very close to a 1.0 in our R squared for a positive correlation, which means that yes, we are paying salary. Our salary is correlated to however many years of experience we have. And then what's going to throw that off? Ideally, a one would be every single point in line here would be going up like this. 45-degree angle starts out here at 0, and then it builds up as time, and each one of these points would be on that line. Now, what drops that R squared down significantly is like what we have right here. There's a lot of points that kind of contradict that correlation. Like we have somebody over here with 26 years of experience that's making $60,000. And then we have another individual over here with less than a year making 145. Now, there's a lot of reasons for that. It could be job title or whatnot. But from this data, we would have a low R squared. So that's what we're trying to find, is that correlation between our salary and our experience. Okay, now back to this. Sorry about that little tidbit. I'm just a compensation math person by trade and discipline, so I get excited when it comes to math. So since we're going to be calling a helper function, we're going to need to take the results of that helper function, whatever it's returning, and put it in a variable. So let's just create a variable. We'll put this as a constant because it's not going to change. We're not going to redeclare it. And let's call this simply R squared. Be incredibly original and just say R squared. And what this R squared is going to do is going to run our helper function. And since we already have a calculate average, calculate sum, let's just call this function calculate R squared. Now, this R squared is going to need two pieces of information, because what we're going to need to find is the sum of the squared residuals and the total sum of squares. And really what that means is we're going to need to find the average of essentially all of our experience, that array that we created. We're going to have to actually find the average of that, so that X, and then also do the same exact thing in finding the Y, or the salary. And so the formula, just to give you a primer of how this is going to work, is we just can't simply write the formula in there and have it calculate for us. We're going to have to build that out. But it is the residual sum of squares divided by the total number of squares, and then less than 1. And what I mean by that is you have 1 minus the sum of squares residual and the sum of square totals when you divide it. So that's the actual formula. Now, the sum of squares residuals, the sum of the squared residuals, is essentially the difference between the actual Y and the predicted Y. And that's where we're getting our line from. And then the total sum of squares is the difference between the actual Y and the average Y. So we need to find, if we had a predicted Y, we would use that model, but we don't. And we essentially need to find the mean of X and Y. But in our function here, we need to pass to our calculate R squared this array of experience and salaries. So our experience is our x-axis, but we need to pass that array. And then we also need to pass our salaries array to do our calculations. And then what we're going to need to do is run a function to actually essentially put that in those input boxes. So let's just call that function. So after we run this and it stores it in a variable, we need to run another function, and let's just call that function display r squared. There we go. And what this is going to take is the result. It's going to take this, because in order to declare this, it has to run this function. When that function gets done, it's going to return it, store it in this variable, and then we want to display it. Okay, so now we need to start creating some functions. Let's create this display squared function first. And when we create this displayed function, then we'll actually work on the calculation piece. So we need to get out of this filtered chart function, and let's come down here and function to display R. I don't think it's going to do this in that, but it doesn't. Not even sure why I did that. Okay, so there we go. So this function display R squared is going to take this R squared, and we can call it the same thing. It's fine. This R squared value, this, and then we're going to want to do something with it. First thing we're going to need to do is to grab our element. And the element that we're going to populate this into is comp R2. Very original and thought-provoking. Took a lot of effort to come up with that. And let's store this in a variable called R squared box. This is going to be equal to the document get element by ID, and that ID is going to be comp R2. And what we should really check is if that R squared box actually exists. Because remember, this is all in our header or our head section, and we want to ensure that that box is populated and available for us to put things into. And we ran into that same issue with our filter drop down. So I'm going to kind of do the same sort of logic and just create an if statement here. And I'm going to check to see if that box is even there, because if it's there, it's going to equal true. We're not giving it any conditions. It's just checking to see if it exists. And if it does exist, then we can take our R squared box variable and set the value to essentially our R squared, what we passed. Yep. And now our R squared, since it's going to be dividing some pretty interesting numbers, we should probably control how far out those decimals go. And if you remember when we were looking at our scatter plot here, in the legend, the R squared is equal to 5.544 minus 4. So that's times 10 to the minus 4. So for now, let's give it a 2 fixed, and let's just fix it to 6. That'll be enough to fit in that box and carry it out, because we're not going to get, with our randomized data, we're not going to get anywhere close to 1, a perfect correlation. It's just not going to happen. I'll be happy if we even get close to 0.1. Okay, and then let's give it something else to do, just in case it doesn't exist. This will help in our debugging. Let's create a console.error, and that error that we're wanting to kick off is R squared well, that's just going to end up as text. R2 is not, R squared div is not found. Something like that, because that way we know we're jumping the gun and it's being called before it's even available. Okay, perfect. So now we got the display piece done. So now let's jump in and create our actual calculation. So as I was mentioning, I'm not actually going to turn this into a math tutorial, so that's a little bit out of scope on this. But I do hope that, I mean, if you are following along, I hope it makes sense. If you just want to jump in and grab the code, I'll make this function here available in our description for this video. But what we're essentially going to have to do is we're going to have to use our trend line and the equation that we use for that trend line for our prediction, for that Y prediction. And if the trend line is linear, which it is by default, it's that just that straight line, the equation is essentially going to be this Y equals, and you may remember this from math class, Y is going to equal mx minus b. And this m here is the slope. The y is obviously the y value, the x is obviously the x value, and then this b is the y-intercept. So we're going to need to grab this and in our calculation, and then we're also going to need to do the square root of sums for the residuals and then the total square of sums. Sorry, I'm just trying to think this out. And we're also going to need to grab the average. In order to do that, we're going to need to grab the average of the x and the y. Now, we're already passing the x and the y here for experience and salaries. So when we create this function is called calculate r squared. It is going to need to take, it's receiving these, but we can call these anything now when it's received. So let's just call it, since experience is x and salaries is y, we'll just do x and y. It'll be easier. And what we're initially going to have to do is check to see if any of these arrays are empty. So let's write a quick if statement here. And if x length is not equal to the y length, or, and this just means that we have more experience data than we have the y data, because they have to be equal in order for us to do this. If we have 5 pieces of data in our experience, we need to have 5 in that. And that's what this is checking here. Or x dot length, we're just picking one, is equal to 0. Then we want to just simply put out a console error as well so we can check it when we're debugging. We'll just say invalid data array must be of equal length and not empty. Okay. So this way, if this doesn't work, then what we can do is troubleshoot it and say, okay, so it's our data, and then we can drill into our data. And if not, nope, return not a number. Okay, and then obviously, if this isn't true, then we just do nothing and continue on. Okay. So the next thing we're going to need to do is calculate the mean of the y. And we did that. If you remember, we created a helper function. That helper function is over here on our total rewards.js. We already calculated our average, so simply we just need to pass the array to this. So calculate mean of x, and this is going to be a constant. Well, actually, let's do the y first so we can find that. Let's do y mean, and this y mean is going to be calculate average, which is that function that we're using, and what we're passing is our salaries, our y. Now it's going to stop what it's doing, and it's going to calculate this and then put it in the y mean variable. Okay, and then we now need to compute the slope. And to do that, we're going to need another function. And this other function we'll just call calculate linear regression. So let's create a constant here, and this constant is going to be essentially this intercept, because we're going to want the slope and the intercept, and we're going to send this in order to fill this object piece here. We're going to need to run the function, and that function is going to be calculate linear regression, making sure that's spelled right, and that linear regression is also going to be our xy. And we will create that in a second. Let me write that down. Calculate, okay. Write that down there. Okay, so now let's declare our variables and run through our averages to find the sum of squares for the residual, sum of square for the total, or the total sum of residuals. So let's create a variable. Now this has to be a let, because if you think about how we're finding the average, we had to declare a variable. Typically it's like sum, set it to 0, and then just keep changing it over and over as it's cycling through its data. Same concept. So since we are changing this variable, it needs to be let, not a constant. And let's just call this sum of squares for residual, and that's going to be equal to 0. Sum of squares residual, or actually, let's just call it residual sum of squares. And then we'll do the same thing for the total. Let's just do SS tot equals 0. And this is going to be total sum of squares. Okay, so now what we're going to need to do is go through our data and essentially find each one of these. And I'm not going to go too much in depth, because this is actually, I need to slow down on going so far in depth. This is actually probably a series in its own. But what we're going to need to do is to write a for loop. And in that for loop, it needs to take a variable that we can call predicted y, and then find the slope and the intercept of each x. So it's going to look something like this. This is our for loop, and we want to let I equal to 0. And then we want to keep running this until I gets to the essentially the end of the x, and then we want to increment this by 1 every single time. And how this calculation is going to look for for this is going to be, again, we need our constant variable, and we call this predicted y, I think we said. And what this is going to be equal to is this slope times the xi, which is this, plus the intercept, this. So where I'm getting this is essentially mirrored. When we come up here, you'll see that our salary is negative 130. That's our slope. Our slope is negative because it's going downhill. Times our experience, which is that x value at the I index or interval, plus the intercept. So what we're essentially doing is we are mapping out the formula here in our legend. Map may not be a good word to put it because map is a JavaScript thing, but we are aligning that to this. And what this actually is this y equals mx plus b. So we just wrote that formula right here and stored it in this predicted y variable. Now what we need to do is handle this SSRES and SS.T. And we're going to use the math.pow. It's called math.pow, power method. And what we're going to do is we are going to take the SSRES and sum it to the math.pow. This is going to be this, and we need to grab the y at each I, and we need to subtract the predicted y, and then going to be a 2 is what it should be. So this is our residuals. Now we need to do the tote, and this is also going to be that. It's going to be, there we go. It's going to be taking this, the current value, and adding it to the previous value, on and on and on until it gets to the end of the x. Now this one, for the sum of the total, if we remember right, it's going to be minus the mean of the y. So we're going to take every y-intercept and subtract not the predicted y, but the y mean. And this should also be 2. And this is going to be essentially how far the deviations are from that mean, is essentially what this total is. Okay, so there is our for loop. So now let's write an if statement. If our SS taught is strictly equal to 0. So if our total comes back and there is 0 deviations from mean, then what that means is we can't actually calculate our R squared because we can't divide by 0. So what we're going to need to do is do a console error here. And that is going to be SS taught can't be 0, cannot calculate R squared. Something like that. That way when that comes up, we know that our total was 0 somehow and something's odd. Typically, this is going to appear if your data is coming over as a string, not a number, because it's not going to register it as any length or anything like that. And then we're going to return not a number. Okay, so we took care of that just in case that does occur. So now we need to actually do the calculation for our r squared. So we can create a constant, and we can call this constant r squared because remember we're in a different function. So we can use this again. This isn't a global function, or a variable. It's not a global variable. The variable is inside a function, so we can use the same term just to keep it simple. And now what we need to do is write the formula for r squared. Now that we have our SS res and our SS total. So that is going to be 1 minus SS res divided by SS total. And then we need to return that back there. Now this is going to go up here in this r squared. So now we have the r squared, and now we can simply display it. So let's come down here and, oh, nope. We got to create another function. Sorry about that. Because we need to create this. So let's copy this and come down here and create that function. Now these functions will go down into our total rewards JS with our average and sum. So what this function is going to do is how we're going to create this function, or how we find the linear regression is first we're going to need the x mean and the y mean. And we can do this by doing this. And this is going to be calculate, we'll just call our calculate average. And we are going to calculate the average of x, which is our experience. And this is going to be y mean. This is also going to go over to that calculate average y. And what we're going to need to do here is remember we're returning an object of slope and intercept. So we're going to need to do a for loop on both of those. So let's declare those variables. We'll call this numerator. And the numerator is going to be equal to 0, not O, 0. And then we will call this denominator. And that is going to be equal to 0. And now we can write our loop to loop through all of this data. And we'll declare our I, and that I is going to be equal to 0. And the I is also going to go as far as the length of x. And we are going to want to increment it by 1. So now for every single element, every single I here, we're going to want to take the numerator and sum it, essentially take the current, add it to the previous, and what we're going to want to do is grab the x at the I and subtract this from the x mean, and then we are going to multiply this by the y at I minus the y mean. So that'll give us the numerator. And this numerator, now I'm not going to get into the linear regression formula because I really don't know how to make the symbols for functions and stuff like that. But you'll have this formula or this function here to where you can just copy it and make sure that your x's and your y's are set correctly. So now our denominator is going to be also increasing And what this is going to be, we're also going to use the math power method. And we are going to take the x at every I, and we're going to subtract the x mean and square it. Okay, so now we can end that line. So outside of this for loop, we need to create this constant and slope because we're building this right here. So we need to create a constant slope variable. And that slope is going to be equal to our numerator divided by denominator. And then we also need our intercept. No, sorry, I was getting something stuck in my throat. We're going to need our intercept. So let's create that constant, intercept. And this variable is going to be equal to our y mean minus the slope times the x mean. So now that we have this all built, we can now return that object of slope and intercept for that data set. And now this is getting returned to this constant so that it can finish on these calculations. So we're having to kind of chain on functions in order to complete a function is what we're doing here. So let's save this and see how we did. I would be incredibly surprised if we did this in the first time go. That was a lot of code we wrote. And unfortunately, Google App Scripts doesn't necessarily have the best, hey, you made a spelling error here, but we'll see what we got. Okay, it's populated. Okay, good. Wow, that's awesome. No spelling errors. That's the first time for me. So if we look up here at our legend, the r squared that it is producing is 5.544 times 10 to the negative 4, and we are producing over here 1, 2, 3, 4. So that is absolutely correct. And let's make sure that it does the same thing here. So we are at 0.022, and this is 0.022. Perfect. So now we have our r squared. I'm going to end this video here. I know that was a lot. I will take our calculate linear regression, our calculate r squared, and I'll put those in our description. So you can just grab them and have them if you need to calculate them. If you do like what we're doing and you find this helpful or beneficial, please hit that subscribe button. Let us know that we're on the right track with content and subject. If you do have a request on you would like to see us put together, or a question on these videos, please drop us an email. The email's in there as well. And until next time, please take care.